Hi everyone, I'd like to welcome you back to part 4 of our home design masterclass. This is the 25th masterclass we've done now, and it's the 4th part of a region build that we've been working on for a couple of classes now, covering different aspects of building regions in Sciencebase. Today we're going to go back to our original build, and last week we focused a lot on the water, getting the waterfall correct, getting the particle system on the waterfall itself behaving correctly. You know, if we go dig that out, we can see all the bits and pieces that are part of this one. One of the things we'll just quickly fix here is something you just noticed then, that actually it didn't actually appear particles until we started holding it down for a second. We sort of saw the first wave come over. One of the ways we can fix this problem, so if we just hit play, you'll see exactly the same thing happen over again, is to actually pre-warm the system. And we click that pre-warm checkbox on the particle system, it'll actually start as if it had been running already. And that means when someone pops into the scene, they won't see their particles just suddenly start to emit. They'll already see a sort of lively, active system from the moment they get involved. Okay, so I'm just going to stop that one. I'll go to part 2, and I'll just pre-warm there as well. Part 3. Now, one of the things I didn't like about this water system before was, one, how this stuff tiled. Sorry, one second. Music coming back on. One of the things we didn't like is how the water didn't tile correctly. And I actually saw a very neat trick by someone on Twitter doing shaders for waterfalls specifically that I actually would like to implement here. And that is to make the waterfall actually have a sort of a highlight on the 90-degree bend. So if we go to, bring up my MS Paint here, the very best. So if we grab the waterfall and we look at it like this, we've got a sort of a like that. If we take a look at that, what we want is we actually want to have a sort of a white foam, particularly around here. We also want to get one down here. Now the mesh here unfortunately doesn't have the bottom part, it's just a flat thing that sort of falls off, and if we look underneath you can sort of see the hard cut. Oh, actually no, we did do it as it's all one mesh, so no, we do have that capability here. Well, that's even better for us. So one of the things we notice is that we want to get a white sort of a foam on these particular areas, and we might also want to do something particularly on this section. Now, one of the ways we can do this is to look at the normal, and we're actually going to edit the shader in a second. So this is sort of a basic bit of 3D math, but effectively we can look at two vectors, that is two directions. So I've got an up direction, and we can look at a sort of a sideways direction like that. And what we can do is we can actually determine how far this angle is in a very quick shader function. And that'll actually, if we set this direction to the up, so we aim for there, and we set maybe another one for the side, well actually, even if we don't, but we can do it off the one calculation by just checking if that's past 90 degrees or not. But what we can do is we can check against the up direction on the normal, that is the direction outward facing on this thing, and then we can actually choose to have foam appear only on these sections. Now it sounds a bit complicated, it'll get a bit easier when I go in and explain this, and there are some fantastic tools for Unity for doing visual shader graph use. I actually haven't played with them enough myself to get confident sort of teaching them, but I would suggest that if you want to, go check them out. Shader Forge is one of them, and it became a free product just a couple of weeks ago. So if you're looking into building shaders and you don't really feel like getting into sort of Notepad and getting down and dirty with the actual shader source itself, which I don't blame you for, we can actually go in and we'll just do this by hand. So if you don't feel comfortable, but sorry, you can use those tools to do exactly what we're going to do in a visual manner. It's probably, for people who are artists and not programmers, it's probably a good thing to go for. So the first thing first, I'm just going to duplicate this water shader. This is based on the one we did for Masterclasses quite a while ago, and we're going to fix a couple of bugs with this one. The first is that the water doesn't flow in the right direction. As you can see here, it sort of flows uphill, and that's because it's using the UVs on the actual mesh itself. And the UVs from this, because we did it in Pro Builder, are a bit of a mess. They're good for what they are, but they're not really built for this particular function. So I'm just going to rename this shader as Waterfall 5. I'm just going to wait for Unity to behave here. While I do that, I'm just going to quickly refill my jig. Actually, never mind. Okay, so we're just going to bring this up in Visual Studio, and that's my preferred IDE for editing stuff because it's got nice syntax highlighting, but frankly there are so many various text editors for this, it's not very complicated to write these. So first things first, I'm just going to rename this to Waterfall 5. Okay. And we're going to add a couple of new parameters to this. We're going to add foam normal when it decides to control back. Okay, there we go. So we've got our foam already. We actually got some foam handling in here. We're not using it at the moment, but we will be in a second. Now I'm going to pack two parameters into one variable here. I'm going to pack both at the start and the end, just so we can tweak this visually and see how we go. So I'm going to go foam normal, and I'm going to call it a vector specifically so I can pack a couple of variables into here. So let's put just so someone who's reading this might have a vague idea on what those packings are. I'm just going to set that up as a float. So we can set this float. Oh shit, so it'll be half. I'm going to take this as a high precision thing. Right. Okay, so now I've got that in place. I'm going to dig down into this surface shader, and this is where it gets a little bit scary, but just to start with, I'm going to make it obvious. So we're going to create our normal based on this. Just thinking the best way to do so. Okay, so I think we've got the in-world normal ready. So I'm going to double check that. No. Do we have a normal there? We might. Just going to quickly check something. Just put them out on the machine. I just want to make sure that I've got these parameters correctly. This is when we get into shader editing. I want to get Unity 3D surface shader world normals. I think there is an input parameter for this, but I'm just going to quickly look it up on my reference machine, which I've got next to me. And someone has got the answer. Thank you. Custom vertex shader. All right, we've got that already, so I'm just going to put some parameters in here. Float 3 world. Okay. Now our O dot world normal equals multiply. We're going to use some weird math here from Unity. That's not correct. Unity have changed this repeatedly since this code I'm looking at here is from 2011, which is unfortunately a little bit out of date. We'll find this. Oh, there is already a world normal. Never mind. Looks like we've got this stuff already, so I don't need to mess with this one. I think. Yes, I think we can. Okay, so going back here, we're going to use the dot product, so I'm just going to create this dot value equals dot, and it's in dot world normal, and we're going to use the vector 3 for up, so 0, 1, 0. Yeah. Okay. So we've got the start of our dot value there, and I'm just going to make it really obvious on the shader as we go. So type today. Mission equals 1, 0, 0 times dot. It's just going to put it on the red, so it should appear red when we use this one. So I'm just going to refresh that file. And then I'm going to want to use an inverse alert function, but we'll get to that in a second. Okay, so first things first, I'm just going to swap this to the new shader. Waterfall River becomes custom Waterfall 5. And I have a problem. Already I've made a mistake. Let's see, what have we got? It's internal data. Okay. I need to add some magic keywords here. Oops. Huzzah, I think. No, maybe not quite. Line 84, I have made a mistake. It's just that. There we go. Okay. Now we should be seeing something here that is bright red, but we are not. So I'm just going to make sure this is set correctly. It is set to Waterfall 5. I'm just going to make it really, really insanely obviously bright. You may notice me manually re-importing stuff. This is just a setting I've got in my editor because I'm dealing with projects that are substantially larger than many of the ones you're dealing with, so I've actually got set Unity to not to monitor all my files because it does slow down a bit when you get to that point. Make sure this is working at all. It might even be from the other side that it's curse of one way. Right, editing the right file. Well, okay, that's a river of lava. This is one way to do it. Let's set this to inbuilt world normal. Just want to have a look at this, make sure it's actually all correct. Interesting, so I'm not seeing the data that I'm expecting to see here, which means that some of this might be wrong. Okay, hold on one second. What I'm going to do is I'm going to go move away from using that and use one of the Unity built-in functions. So I use world normal vector over normal. I believe that should do the job. This is where using a visual editor can be useful, because those things tend to work a bit better. I'm still not seeing our change that I want. It's a little bit disturbing because that should be showing something. Oh. Right. Because if we're doing this correctly, we should be seeing something, probably a bit of a bluish color, creep into the object, because we'll be previewing the normals. There we go, that's what we're looking for. Or at least maybe what we're looking for. So look at it from the sides, it should. Not quite the color we're looking for. Just making me suspicious that there might be something going on the actual mesh itself. It may not have accurate normals. We can preview that using the built-in Unity previewing tool. So we can actually go from here on the scene mode, we can go shaded, and we can just go down to normal. And it is not writing a normal at all, which is, well, odd. Maybe due to the fact that it's in the transparent queue. There's something we can probably fix. Oh, right, because it's in the deferred path. Okay, that is actually because it's transparent. Transparent objects don't render the same way that normal objects do. So I'm just going to quickly pop this out of the transparency queue. To do that, I'm just going to comment out these tags. And on the surface shader part, somewhere, I'm going to take that line off. Now I should be able to get a good look at it. I have a suspicion that something is going wrong with the actual model itself that we've got in here, and that's why it's misbehaving, but we'll quickly find out. So let's have a look at the normal. And now wonder why that's not appearing at all. Okay, that's in the right path. It's not doing anything silly. Default shadows, surface standard outputs. That's all normal. It hates us. Just going to quickly redo this. Go back to normal, and we'll just see if we can preview it the hard way. Now, because this model was built with ProBuilder, I actually think there might be a technique for getting ProBuilder models to actually insert their normals manually. So I'm just going to find the model itself. There we go. Edit polyshape. Have I done something horrible? Yes, I have. Ah. I'm just going to quickly reload the scene. Save regularly. We're going to be messing stuff up. Should have read that warning. Okay, so we'll grab this again. Okay, and I'm going to open up the ProBuilder tools. So it's in Tools, ProBuilder window. And I'm just going to make sure that the normals are set correctly. So I'm just going to confirm that to do the job. I think that I should. Let's have a look at this. It's got a normal. There is something very weird going on with that. Okay, well, nonetheless, I think that should behave. So there's any geometries that it looks right to me. But if something goes horribly wrong, we'll take a look at it in a minute. Okay, go back to our waterfall material. Okay, back to radioactive green. Okay, so just while we worry about that in a second, I'm just going to take that radioactive green off. So I'm just going to comment out the emission line I'll come back to that in a second. Okay, so one of the next things we want to do just on this one as well is get the water moving in the right direction. This is a similar process to before. We're actually looking at the world position when generating our UVs. So what we'd normally do for this kind of thing is we'd consider perhaps like a triplanar shader. And triplanar shaders basically sample 3 points, and that means you don't actually have to worry about UVs. Now, at this point, we do actually have valid UVs for the most part. The problem is that the directions are all wrong. So what I'm going to do is I'm going to actually make the animation based on 2 parts of the UV. I'm going to go for the world position, and that's going to be flowing in one particular direction. And the other thing I'm going to do, I'm just going to grab a cube. I'm just going to work out which way is actually which. Okay. All right. So this is a unrotated object, so we can actually see the blue cursor is going forward, and that's the z-axis, as you can see up here in the little widgets. I'll give you a little hint. So we're going to go for z forward on our animation. I'm just going to turn animated materials on as well, so we can actually preview this and we can see that immediately it's going the wrong way. So in here we've got the animation is built through a couple of things. It's built through this time parameter, and it's basically the time, so the UV is getting tiled here. Now instead we actually want to look at basing this on the world position. So the first things first is I'm going to set that to, I think we'll make it world pos dot. We will find out in a second. Okay, so I think we do it based on this. We might just mess with this one a little bit until we get it right. Okay, so float to in.worldpos.z. Quite sure that's right, and we really should be copying this to a variable. In fact, I don't know why we haven't. I'm just going to hang on to this because that was our original. Comment that up at the end because we might add that at the end. Okay, now if we import this one, it should flow, I think, in the right direction. It might also go very weird. This might be just a lack of tiles. It might also be because I screwed it all up. Which I think is the case. It probably is plus. I think that's because we're using the UVs. So what we want is we want to use the UVs for one half of this, but we don't want to use it for the other half. So I'm actually going to start. Get a little bit complicated. I'm actually going to start using one set of UVs for this, but I'm not sure I actually should be able to. Let's have a quick look at this material setup. Okay, so with the exception of the normals. Okay, so the normals are using tiles. So I'm going to add a small function here, float to animate. just going to declare this little function here. Now this I'm doing just because I can do this a bit more accurately if I'm doing it this way. And I can do it more consistently across all of them without having to mess them all around, because we are going to have to do a bit of fidgeting. I do want to hopefully finish this up shortly because I've got a couple of things I want to cover off today. So we're going to return in.worldpos.z plus timex. Okay, and I want stuff the words in here. I'll pass that whole object in. Okay, let's have a look at this. With some luck, it's either flying in the wrong direction or it's working. Only one of these two things will be true. Well, it's looking a bit better. I've got the numbers wrong, that's for certain. And I think there's something wrong with the animation. I think the animation is not very fast. There is something happening there, I think. Might be very slow. Just going to set those up, speeds. Worlds at ZPOS, and I'm going to set that to 0.25 as well. Now I'm hard coding variables in here that I really shouldn't be. You want to expose this to an inspector so artists can edit them on the materials if you're going to be making these materials for other users to play with. But for our masterclass, I'll just quickly hard code those. Okay. Wrong direction, but we're making progress. Okay. So that's 5. And I'm going to subtract it because I want water moving in the other direction. Now that's a bit of a sharp cliff, and that's partly because of the UVs that are attached to this. I have decided to pick some of them. The other reason is that we're actually only using the X coordinate when pulling this. I'm going to actually add the Y. The Y. Sorry, we're only using the Z coordinate, but I'm going to add the Y. The Y to it as well. I'm going to add the plus. Now this is only going to work on the river going horizontal because we've tied the Z-axis here. Now you can do a bit of math and actually multiply something is not quite right there. So I might go back to the previous value there. That's why I'll take that off as a minus. Difference, but it's just a matter of dialing these parameters in. Yeah, that better. Okay, when we add these particle systems, which I also need to pre-warm because to get these quite even right first time around. That's not too bad. Okay, so I still need to solve the problem with normals because I'd like to get the world normals in here and actually highlight based on that. So one of the things I'm just going to quickly test is actually what the normals even look like. Normal normals. So O.normal. And have a look just to see And again, this is going to go glow, but yeah, you can see there's definitely something going on with the normals on the generated mesh, that it's only ever going out in one direction, which is wrong, and we'll need to fix that. But it's also an indication that that's why our shader wasn't working before when we put the sort of the neon red on it. If I grab a capsule, which is a nice round surface, and put this same shader on it, you're going to do the same thing. Huh. You very well may. Okay, we need to have a look at this. Because what we want to see is we want to see the actual object have different colors and different angles of the surface. There's something misbehaving here. Okay, I might have to investigate that one. We'll come back to that next week. Moving on. One of the things we were going to want to play with is lighting in particular. Now we've got an okay lighting setup in here because the region is reasonably well lit. We have a nice sort of day-night, sorry, not day-night, we've got a nice sunlight, we've got a decent environmental ambient setup that's actually generating most of its ambient light off the skybox. And that means that our test avatar that's already in the scene is reasonably nicely lit. However, we are going to actually want to bounce light around the scene a little bit more, and I pointed this out before that one of the ways you're getting a really good looking scene is having lots of bounced soft area lights in the scene. Now unfortunately there's really only one way to do that, and that's baked lighting. Now there are other ways of doing it as well, particularly in sort of simpler scenes. You can sort of hard code the lighting values in a scene, but for a more complicated one like this, it's usually a good idea to bake the lighting. Now, one of the things with baked lighting is that outdoor scenes and baked lighting don't mix very well. It's sort of an oil and water situation. Nonetheless, you still want to use it. So what I'd like to do is actually go into a little bit of the best practices on lighting outdoor scenes with baked lighting. I will not have enough time today to actually do a lighting bake at the same time, because we've only got 20 minutes left, and a light bake could easily take that amount of time to actually run through. This is one of those ones you sort of leave overnight when you're happy with sort of how it's previewed. So that apparently is the center of our terrain. I'm going to add a component from our editor pack called Probe Drop Plane. If it doesn't show up there, it will here. Probe Drop Plane, we'll just drag that on. As you can see, it brought along a light probe group with it as well. Now the key with the Probe Drop Plane is it basically drops lighting probes which sample lighting in a particular area in the scene. And it drops them all over the scene according to sort of a grid. So I'm going to make this grid bigger. I think we made this scene 500, if I'm remembering. It's 500 meters. That looks right. Someone will tell me later that I got that wrong. But I'm also going to move this so it's higher than the tallest object in the scene. And we'll set the... Nope, that's all good. Okay. I'm going to untick the roof function. Actually, we'll leave that on. I'm going to leave the density not at 5. I'm going to bring the density up. The density is basically how many meters per probes there's going to be. So every 5 would mean we'd get thousands, which may or may not be okay, but in this case, I don't want it. Okay, so the first things first when I do that is it's placed a lot of little probes in here, and the density is not good enough. What we want is particularly want density in places around here, like for instance there's a shadow to light transition. We want a higher concentration of light probes in those areas. We want more light probes in areas where lighting is more complicated. Like for instance, this section here, this is right where we're pointing at. This is really straightforward lighting. There's no interference with shadows. There's nothing nearby that the light's really bouncing off, so that we don't really need a complex lighting setup. But again, down here, we absolutely do. There's an interplay between the cliff and the point here. If we go next to one of these rocks, for example, there might be as well, because we're going to get sort of a lot of bright light bouncing off the whiter rock than we are of the ground texture. Now, it's partly not accurate in the scene. The scene should, generally speaking, rocks are generally the same color as the ground around them, but in this scene it's not. But that's the case for anything in the scene. If you've got a complex object like this, the start of the home we started building. That's very white. We're going to want a lot more probes here. Now, the way to do that is to grab these drop planes. You can actually just duplicate it. And I'm going to duplicate it, and I'm going to shrink it. I'm just going to create a couple of these around that are a bit higher density. So this area here, I'm going to set the density up to 5. And I'm going to update. I'm going to take the roof off this one because we don't need a ceiling on this. And now you can see around this particular area we've added a whole bunch of extra probes, and that will give us a better lighting setup there. The forest over here, we probably want a little bit of a higher density too. So let's drop those down, and I'll place one here too. Shrink that a bit. I forgot to do the update on that one. There we go. Okay. So that means when we look down here, we've got a lot more lighting information stored. Light probes are basically the equivalent of light maps for real-time objects. What they do is they sample light from 9 directions around the probe itself. So it's sort of 3 above, 3 in the middle, and 3 below. And when those positions sampled at runtime when an object is nearby, what they do is they just pick up the nearest 3 probes and then sort of build a lighting setup from there. And that means you can take advantage of baked lighting in real-time objects. So real-time objects don't look odd when you bring them into a scene. Like for instance, you brought baked lighting into other virtual worlds and things in the past. You know that the avatars never sort of pick up the objects nearby. And that's really useful when you're building scenes that have got really complicated lighting setup. I've got one of my co-workers has been messing around with my club scene. And I'm going to just quickly pull that open as a really good example of why light probes need to be sort of baked at a sort of higher density for things. And I can show you this scene is very much a good lighting demo. Just saving my project first before we move on. I was in the Neo Club. So actually, I've got a copy of it in this project. It was the blue one. So this one is the club region you may have seen before. This one's got a much more diverse lighting setup, as you can see. It's a fairly sort of complex build as far as lighting goes. There's lots of different lighting coming from different places. And when we've got a real-time object, there's an object that's not been baked. As you can see, all this stuff has got baked light maps attached to it. I can turn on the light maps to have a look at it. So if you look here, you can see this is what the light map looks like. If we bring an object into the scene, in fact, I'll set this guy up as a pair of these. So I'm going to set this cube here. I'll in fact use a capsule because again, capsules are good for showing complex lighting. So I'm going to take 2 of these around the scene and we can have a look at the effect of light probes. This one's got no light probe information. That means it's relying entirely on real-time lights in the scene. This one has got the baked lighting attached to it, and immediately you can sort of see those differences that we bring it into an area. Yes, there is some influence of the light. There's lots of little specular bits and things. But what those light probes are giving us is that really nice, bright, soft lighting that is otherwise missing. And that really shows up when we bring an avatar into the scene. So if I follow the same process here, we've got this girl here, and I'm going to set her twin up as avoiding not using light probes. You can see those little light probes there. So I'm going to set my lighting, turn off probes. As you can see when we drag these around again, similar thing. Now, one of the key things about light probes is that it means things like baked lights up here. If there's a soft orange light up here, we're picking up all of that. And if we move it out between two distinct lights, which I think, well, here works. Maybe not very strong, but as you can see, we've sort of got that nice orange from this side, blue from this side. So when we come back to our home scene, we're going to try and get that sort of same effect where we've got nice sort of diffuse lights, we've got light bouncing off the ground. And to do that, we've already set up everything we need to do. All we have to do is finally, when we're ready to go, and that is we've got these light probes all over the scene, that's the main thing you need to do. You need to hit generate lighting. Now, one of the things you're going to run into immediately doing an outdoor scene is that this will produce a really large number of light probes. The other thing we want to do is probably not use the Enlighten light mapper. We'll go over to the progressive light mapper, which produces faster results. It does generally produce better quality results, although it is still an experimental feature of Unity, and it is not the world's most stable feature. You will want to save your scene before you start doing light mapping this way. The other thing we want to play with is, again, this light map resolution. Now, right now, the light map resolution in this scene is 40 texels per unit, and that means for every 1 meter squared, that is why 1 by 1 meter, or the size of the default cube, we have 40 pixels of light map across and 40 pixels of light map down. And that means it's basically the same size as roughly a 256 texture sitting there. And that, well, actually not 256, but a 64 texture per meter that's in a scene. And when you've got a lot of objects, like for instance a large terrain, that number very quickly becomes a very large number. If I bake this scene as it is right now at that 40 texels per unit value, my guess is I would probably end up with half a gigabyte or more of light maps in the region, which is going to burn through your region quota quite quickly. For outdoor scenes, you get away with a lot less, particularly if you've got you're relying more on things like light probes and real-time lighting than you are on baked lighting. And to do that, I would probably go with the value of about 7 for this scene. That should knock it down to maybe 30 meg worth of light probes, light maps. We've done this. And when you're otherwise good to go, we can just hit the generate lighting button. So I'm just saving my scene. And as I said, this is a really good practice if you're using the progressive light mapper. The Enlighten one is generally more stable, but I find it's significantly slower. The Enlighten light mapper on these kinds of scenes can take hours, whereas the progressive one should only take about 20 minutes. It's probably a little bit longer if we've got right now, but if we go start the scene, I don't know how long this will exactly take, but it'll give us a little preview, and maybe we can get a rough idea of how this will look when we go for it. As long as Unity doesn't crash, which it probably shouldn't. It should be okay. Okay, so this one's currently estimating 24 minutes, and that time will actually go down. It'll probably have about 15 minutes. Probably a little bit much for now, but what you will notice is that the light mapping system is going to start updating things immediately. So, no, 7 minutes. Well, actually, we'll be pretty quick this one. And when you're happy with it, you can actually stop it before it's completed. So actually, in this case, it's only 16 meg of light maps are associated with this region. We probably don't get a lot visible here. If I go to the view base light map, we don't have much of it left, but once we bake it, we'll actually see the values. So this will end up quite small. Okay, so we've probably covered a couple of really basic things here. I think I covered wind zones in a previous one. That was something I wanted to make sure this was covered in the same. No, I didn't actually cover wind zones. Okay, so this is something just to make the trees a little bit more foliagey. I thought I did cover this, but apparently I didn't. Or at least I didn't save one in the scene. Wind zones can be added to the scenes. That is from the game object, 3D object, wind zone. And wind zones basically act as an emitter of wind. Now there's a couple of variations in the wind zone. There's the directional one, which means that when we align it, you can see that all of our trees are blowing quite fast and hard in that direction. We can control that using the modes. So I'm just going to set the default values are way too strong, so that we total this right down. And that gives us a sort of much nicer, probably still a bit too much. We just want to get enough that you can sort of see there's something going on here, but not very much, which we probably should be able to see now. Just a little bit, but we've still got quite a lot of strength there, so I'm just going to put the strength back. The other trick with these guys is that the direction actually influences how strong they are. So if you notice that they're strongest when they're facing flat, and they're actually weakest when they're not facing flat. So if you want to animate them on and off, this is a great way to do it. So that's the first type of wind zone. The second type is the non-directional type. This is good for, I don't know, like a helicopter landing. If I place one here, which is a copy of the other one I've got, and set the mode to spherical, you can see here that I've got the spherical controller, and I can actually set the value up a lot. So if you've got a helicopter coming down, for example, this is a way to sort of simulate the effects. Particularly it's good in animations if you're doing something like, I don't know, a Dragon Ball Z-esque series of fight animations. It could actually be cool to spawn a wind zone while that's happening, because all the trees around and anything else that's configured to interact with wind will actually play with it. It's one of those cool little features that's been built into Unity for a while, but don't get talked about too much. Okay, so next things that we were going to do, I was actually going to look at doing a couple of tree leaf falling patterns here, but I'm not quite sure we'll get up to that today, because we've only got a couple of minutes left. But what else would be worth covering off in this region? Because I think we're, besides the building of actual room itself, which is something that we've been putting off for a couple of classes now, I would like to get into sort of the dressing up of the effects and things like that. One of the things I might go into next week is covering off the PA particle system, which is an extension for Unity that's worth grabbing if you do like to do environmental things, because it lets you build quite dense particle fields in a way that the default Unity particle system really chokes doing. I have actually used it in one of the building classes I did when I built that desert wall a couple of weeks back, or a couple of months back, I should say. So I'm going to finish up there, I think, and we'll continue on next week with a few more bits and pieces. For now, I've got my office hours, so if you are watching along and want to hop into the assembly region, I'll be starting office hours there in just a moment. Okay, thank you all for watching, and I will see you all next week.